Imagine the biggest city the world had ever seen. A place with 1 million people, no electricity, and summers so hot the air itself seemed to shimmer above the streets. While smaller towns across Asia were being deserted because of unbearable heat, Chang'an was somehow thriving. How could that be? When modern architects began studying the ruins, they stumbled onto something that completely upended their understanding of how to keep buildings cool. What they uncovered sent them scrambling to replicate a technology that had been perfected over 1,300 years ago. But the real surprise wasn't just what they found. It was the realization of what humanity had forgotten. During restoration work on the Forbidden City, research teams recorded temperature readings that defied modern expectations. They discovered that buildings constructed back in 1406 stayed a remarkable 8 to 12 degrees cooler than the streets outside, without using a single watt of electricity. No fans, no motors, and no maintenance for more than 6 centuries. Step into the Hall of Supreme Harmony today and you'll feel it for yourself. That immediate sense of relief as a soft wave of cooler air wraps around you. Every wall, doorway, and angle had been designed with such precision that today's physicists describe it as nearly perfect. But what truly stunned modern engineers was this: those ancient structures didn't just stay cool. They actually became cooler the hotter it got outside. The science seemed backwards at first, until researchers realized the brilliance behind the design. Warm air naturally rose through vents built into the rooftops, while cooler air drifted in from below, creating a constant, effortless cycle of airflow. The bigger the temperature difference outside, the stronger the cooling effect became. It was like the buildings themselves were alive, breathing harder when the air grew hotter, pulling in what they needed to stay balanced. Ancient Chinese builders had achieved what our air-conditioned world still struggles with today, working with nature's forces instead of fighting them. And yet, that was only what happened on the surface. What lay beneath the ground changed everything scientists thought they knew about climate control. When archaeologists began digging under those old foundations, they discovered the secret wasn't just in the architecture. It was in the earth itself. Just a few feet down, the temperature stays steady, usually 10 to 15 degrees cooler than the sun-scorched air above. The ancient Chinese didn't just know this. They designed entire cities around it. But they weren't simply digging basements or storage pits. Detailed analysis revealed they had intentionally chosen materials that turned their foundations into massive thermal batteries. Heavy stone absorbed the day's heat and slowly released it during the cool night, storing comfort for the hours people needed it most. The brilliance didn't stop there. They used different materials with distinct purposes: dense stones for absorbing heat, special clay mixtures for walls that managed temperature perfectly. These ancient designers weren't guessing, they were engineering. And somehow, they'd done it so well that their creations still outperform many of our most advanced buildings today. These ancient builders even thought about airflow beneath their feet. The underground spaces weren't just storage rooms. They were meticulously ventilated chambers that stayed cool and dry, preventing moisture from building up. Air channels connected those lower spaces to the living quarters above, creating a kind of natural air conditioning that never shut off. The secret lies in how the courtyards were connected. Each one had a specific size and purpose, and together they formed a thermal network. Hot air would rise and escape through larger openings, while cooler air rushed in through smaller ones, forming natural wind tunnels that refreshed the entire compound. And the hotter it got outside, the faster that airflow moved. But make no mistake, this wasn't guesswork or luck. The builders followed precise mathematical ratios laid out in ancient manuals. Those formulas determined the exact proportions that produced ideal air circulation, a kind of ancient version of modern wind tunnel testing. You can see this mastery in action at the Lama Temple. There, multiple courtyards work together in harmony. The reception courtyards are designed to channel airflow for comfort during gatherings. The living courtyards balance air movement with privacy, while the storage courtyards keep a steady, cool temperature perfect for preserving supplies. Positioning was just as important. Northern courtyards stayed shaded and cool, shielded from the harshest sun. Southern ones caught and stored warmth during the winter months. Eastern and western courtyards handled the shifting heat of morning and afternoon. Entire neighborhoods functioned as one enormous, interconnected cooling system. Each home was a cog in the larger mechanism, sharing cool air through linked passages. And it wasn't just personal comfort at stake. If one household mismanaged their airflow or blocked a passage, the whole block could suffer. Even the covered walkways served a purpose beyond shade. They acted as gentle transition zones, helping people move between areas of different temperatures throughout the day, like walking through the zones of a perfectly tuned, self-regulating air conditioner powered by nothing but nature. But staying cool was only part of survival. In that kind of relentless heat, something far more dangerous could strike, and it came from the dinner table. At over 100 degrees Fahrenheit, bacteria multiply like wildfire. Eat something contaminated, and you could be dead within hours from food poisoning that even today would be hard to treat without modern medicine. Yet somehow, Chang'an kept 1 million people alive through scorching summers without widespread outbreaks. Archaeological studies revealed how their buildings weren't just homes, they were integrated preservation systems. Each space, each chamber served a role in protecting different kinds of food. Perishables, grains, fermented goods, everything had its place, stored under precisely the right conditions to stay safe in the heat. The more we uncover about their methods, the clearer it becomes. These ancient architects didn't just build shelters. They engineered entire ecosystems of survival. Below the surface, those cool underground chambers served more than one purpose. They were ideal for storing root vegetables and cured meats, staying naturally chilled even when the city above baked in the summer heat. Rooms facing north were reserved for dairy and fermented foods, protected from the direct sun. Ventilated storage spaces kept grains dry and safe, avoiding the moisture that could easily turn deadly in such a climate. But their greatest breakthrough wasn't just about keeping food cold, it was about controlling life itself. They had mastered the art of fermentation, harnessing good bacteria to preserve food, while suppressing the dangerous pathogens that thrived in extreme heat. Their architecture and food science worked together like a single, intelligent system. Fermentation rooms were carefully designed to maintain exact temperature ranges through strategic placement and airflow control. A few degrees too warm and harmful bacteria would take over. Too cool, and the beneficial microbes responsible for preservation would stop working. The margin for error was razor thin. Even drying areas were built with precision. Air moved just fast enough to remove moisture but never so strong that it overheated or spoiled the food. Their storage rooms, cooled by passive airflow and insulated materials, could keep provisions safe for months without fail. And they did it all without a single refrigerator, without chemicals, without any of the technologies we take for granted today. Still, these ancient systems managed to sustain populations larger than most modern cities. But none of it functioned on its own. The key ingredient wasn't stone, wood, or clay. It was knowledge, human knowledge. And the cost of losing that knowledge could be deadly. Operating these systems took an understanding more advanced than most modern building manuals. Every member of the household had a role in managing airflow and temperature, because one mistake could mean heat stroke, spoiled food, or worse. Master builders weren't just craftsmen, they were scientists and teachers. They passed down their skills through formal apprenticeships as demanding as medical training. Students learned to read the wind, to track the sun's movement through the seasons, and to balance heat and humidity like living instruments. One of the most remarkable texts from that era, the Ingenious, compiled in 1103, documented these principles in astonishing detail. It outlined exact proportions for courtyards, methods for managing ventilation throughout the year, and guidelines for choosing materials suited to different climates. Daily operations in these homes were far from simple. Families opened and closed passages based on wind direction, adjusted window coverings to balance heat and light, managed water features to fine-tune evaporative cooling, and kept a close eye on storage chambers to maintain the right preservation conditions. Children grew up learning this just as naturally as they learned to read or write. Thermal management wasn't an abstract science. It was survival woven into the fabric of everyday life. This knowledge passed down through generations ensured that someone always knew how to keep the household systems running safely. Communities shared discoveries along vast trade routes, testing regional techniques and refining them until only the best survived. Over time, these lessons evolved into building standards that reached every corner of the empire. The principles laid out in the Ingenious emphasized what we now call sustainable design. natural ventilation, strategic shading, and thermal insulation achieved through careful placement and orientation. But back then, this wasn't an environmental philosophy. It was survival science, knowledge written, practiced, and perfected through centuries of adaptation. And here's where things take a surprising turn. The truly shocking part about this ancient wisdom wasn't just how advanced it was, but how much of it we've forgotten. What's truly mind-blowing is that these thousand-year-old methods don't just compare to modern technology. They often outperform it. The numbers back it up. Take the Pearl River Tower in Guangzhou, for example. When engineers blended traditional Chinese courtyard principles with advanced modern materials, they slashed the building's energy use by an incredible 58% compared to a standard office tower. Today's architects aren't just curious about these old techniques. They're racing to bring them back. Studies show that passive cooling can cut a building's energy demand by anywhere from 30 to 60%. And beyond efficiency, it offers something no mechanical system can promise: reliability. These ancient designs kept people cool century after century without maintenance, power lines, or moving parts. Compare that to our modern HVAC systems, energy-hungry machines that constantly need electricity, filters, and repairs just to function. And when those systems fail, the results can be catastrophic. We've already seen what happens when the grid goes down. Think back to the Texas freeze in 2021. More than 4.5 million people lost power, and hundreds didn't survive the cold. Or the brutal European heat waves of 2023, when temperatures hit 104 degrees Fahrenheit in the UK. Electrical grids buckled under the weight of millions of air conditioners running at once. And when the power failed, most modern buildings became ovens. But not all of them. The structures that stayed habitable, the ones that actually kept people alive, were those built using the same passive design principles ancient Chinese architects mastered a millennium ago. Thick walls with high thermal mass, carefully planned ventilation, and balanced airflow allowed those buildings to stay cooler for longer, even with no electricity. Modern sustainable architecture is finally catching on, rediscovering what the ancients already knew. The best systems don't fight the environment, they cooperate with it. Today's most advanced green buildings use the same fundamental ideas: earth coupling to stabilize indoor temperatures, heavy materials that store and release heat naturally, airflow channels that move air without fans, and layouts where every part of the structure has more than one purpose. As climate change drives more frequent and severe heat waves while power grids grow increasingly fragile, these aren't just historical curiosities. They're survival tools we can't afford to ignore. And here's the real irony. We've poured billions into developing energy-hungry cooling systems that are at their weakest exactly when we need them most. Meanwhile, the old-world solutions that worked flawlessly for centuries are sitting right in front of us, waiting for someone to take them seriously again. The sad truth is, many of today's building codes actually ban the use of these ancient methods. Modern regulations insist on mechanical ventilation systems instead of natural airflow. They favor lightweight materials that heat up fast instead of dense, temperature-stabilizing walls. And they promote sealed environments over breathable buildings that adapt to their surroundings. Thankfully, a few forward-thinking architects and cities are beginning to turn that around. Singapore's public housing now includes design elements inspired by traditional Southeast Asian cooling systems. Developers in the Middle East and across parts of China are reviving courtyard-based layouts that echo ancient prototypes. The real challenge ahead isn't about technology. It's about mindset. We've become so dependent on machines that we've forgotten how to let nature do the work for us. And with global temperatures projected to rise another 2 to 4 degrees Fahrenheit, and extreme heat events growing more frequent each year, remembering those old lessons might just be the key to surviving what's coming. Power grids are becoming more fragile as old infrastructure struggles to keep up with record-breaking demand during heat waves. What we call passive cooling isn't just a green idea, it's real resilience engineering. Keeps working quietly when modern systems break down. And since extreme weather is now more of a routine than a rare event, knowing these techniques isn't just interesting trivia, it's survival know-how. Centuries ago, the ancient Chinese managed to keep nearly 1 million people comfortable in the city of Chang'an, even through brutal summers, using nothing but simple physics. Those principles haven't changed because the laws of nature don't shift with time. they're constants. You can actually test the concept yourself. Next time it's sweltering outside, go down to your main floor or basement and notice how the air feels cooler. That coolness you sense is the same earth-coupling principle that once cooled entire ancient cities. Most folks feel it but never stop to realize it's a form of elegant, time-tested engineering. Take a walk around your neighborhood and really look at the older homes or buildings. Notice the deep overhangs that shade windows from harsh summer sunlight but let the warm winter rays in. See how thick walls stay naturally cool even on the hottest days. Pay attention to how the windows are positioned. They're not random. They're placed to invite airflow, creating a natural breeze. These are all ancient design tricks, rooted in Chinese architectural wisdom that's over 1,000 years old. You can even give your own home a score based on these 5 age-old principles. Ask yourself, does my house use heavy materials that slowly absorb and release heat? Does it let air move naturally without the help of fans? Does it block out summer heat through shading and smart orientation? Does it use the Earth's cooler temperatures to its advantage? And does it allow hot air to rise and escape while pulling cooler air in? Chances are, most modern homes would fail on every single one of those points. They rely entirely on power-hungry mechanical systems that stop working the moment the electricity goes out. As severe weather becomes more common and our grids more fragile, understanding these passive cooling methods isn't just an academic exercise. It's practical, life-saving knowledge that can also cut energy bills drastically. Have you ever noticed how some old buildings stay surprisingly comfortable without a single air conditioner running? What passive cooling features have you seen in traditional architecture? I'd love to hear your experiences. Share them in the comments below. And if this made you rethink ancient engineering, if it opened your eyes to how the most advanced solutions might actually be the oldest and most proven ones, stick around. Subscribe for more explorations into forgotten innovations that could help us fix the modern problems we created by turning away from ancient wisdom.